Okay, we have here today an interesting integral from the UNSW integration B 2020. This was A1. We have the integral of x minus 1 over x plus x squared ln x dx. Okay, I decided to do two videos on this, doing it two different ways. The first way was really quick, and I'll provide a link to that other video. The way I'm going to do it here is a little bit slower, but I think maybe it's more intuitive, and this is actually the way UNSW did it in their answer key. Okay, to get started with this, what we need to do is we really need to deal with this natural log x. And what I did was spend some time playing with this because it looks like, the derivative of natural log x is 1 over x. We don't have 1 over x anywhere in this problem, but it seems like we could create it. I mean, we could factor out an x here. But what I'm going to do instead is I'm going to make a u substitution. I'm just going to call my u equal to ln x. We can get a value for x just rearranging this and writing it as x equal to e to the u. I'll go ahead, take a derivative to find a dx value. So dx is going to be just e to the u du. And I think it'd be nice to have a value for x squared. So let's just square this, and we'll have x squared equals e to the u squared, which I can write as e to the 2u. So now we'll just go ahead with this. So our x value is going to be e to the u minus 1. Then in the denominator, we have e to the u plus this thing, which is e to u. Natural log x is just u. And our dx is going to be, we'll put parentheses here and write this as eu du. But then I can cancel e to the u with this here, write this as a 1, cancel that with one of these, and this is just going to become e to the u. Then let me just rewrite it to clean it up. But now this integral is actually pretty easy to deal with. What I want to do is, I just want to set up a u substitution. So what I can do is multiply by e to the minus u over e to the minus u, or just 1. Okay, so now we'll just distribute everything in and rewrite this. So e to the minus u times e to the u is just 1 minus e minus u du. E to the minus u distributing to the 1 gives me this. Then here, e to the u times e to the minus u is just 1 times u, so I'll just have a plus u right here. But now I'm in good shape for another u substitution right here. If I just make this, not u, we already used u, so we'll call this t. So we'll do a t substitution over here, making t e to the minus u plus u. I'll go ahead and take a derivative, so dt is going to be minus e minus u plus 1 du. But then we have exactly our dt right here, just in a different order. Okay, so we can go ahead with this, and that's just going to give me the integral of dt over t, but that's just natural log absolute value t. And then we just need to back substitute, but I think what I'm going to do is get this t value all the way back to x. So going backwards, if e to the u is x, then e to the minus u is going to be 1 over x, and u is just going to be ln x. So I can write my t like this. So now I'm ready to back substitute with this value. So for my final solution, we just have natural log absolute value 1 over x plus ln x plus c, and that's it. Okay, so let me know what you like better, fast way or slow way. I know everyone always votes for the fast way, but maybe for once the slow way will win. Thanks everyone for watching. Have a good day.